In this video, I'm going to solve this second order non-homogeneous differential equation. And I'm going to use the method of undetermined coefficients. And this is the differential equation. The way we solve these types of equations is this. We kind of break it into two pieces. One is the homogeneous part, the other one is non-homogeneous part. We solve the homogeneous part first, we get a solution, then we try to find a solution for the non-homogeneous part, and then if we find one successfully, then we combine them. So the final solution or general solution for this non-homogeneous differential equation becomes y of t is equal to y sub h of t, which is the solution to the homogeneous part, plus y sub p of t, which is the particular solution or one specific solution for the non-homogeneous part. Now, this is going to be the homogeneous part of the corresponding homogeneous equation, y double prime minus 4y prime minus 12y is equal to 0. This is a second order differential equation with constant coefficients, and we know how to solve it. Our solution is going to be of the form e to the power rt, right? And then we could take the first derivative and the second derivative and then plug it into this equation. If we do that, we get the following characteristic equation: r square minus 4r minus 12 equal to 0. Actually, after taking the derivatives and then inserting those into this equation, we get this equation. And here, e to the power rt is not going to be equal to 0 because it's an exponential function. And this, in that case, must be equal to 0 because we have a product of two factors that leads to 0. Now, if we take the r square minus 4r minus 12 equal to 0 and just factor it, or you may use a quadratic formula, we get r1 is equal to 6, r2 is equal to negative 2. So your solutions are going to be e to the power 6t and e to the power negative 2t. So the general solution is going to be y of t is equal to c1 times e to the power 6t plus c2 times e to the power negative 2t, where c1 and c2 are some constants. Now let me go ahead and do the non-homogeneous part. So how is my non-homogeneous part going to look like? Which is going to give me the particular solution. So that means we are going to have on the right hand side 6t e to the power 3t. Okay. Now my assumption is going to be that y particular or y sub p is going to be a times t times e to the power 3t, okay, plus b times e to the power 3t. Now, this is my assumption that this is going to be a solution of this non-homogeneous differential equation. So, if my assumption is true, I could just plug it into the equation and then kind of compare the similar terms on both sides and take the coefficients to find the constants a and b. If we plug in these values into this differential equation and simplify it, we finally get a is equal to negative 2/5 and b is equal to negative 4/75. By the way, these steps are pretty straightforward. It's just bunch of algebra. So this is your y sub p. This is the first derivative. You use the product rule for this one, and the other one is very simple. And again, you take the derivative of y prime to get the second derivative, and then you plug it in and simplify. Okay, that's about it. There is no mathematical complications here. So you do the algebra and you have two unknowns with two equations. You end up getting a is equal to this, negative 2/5, and b is equal to negative 4/75. And let me kind of elaborate things here. There is one thing I would like to mention here. So look at this equation, okay, this line. And after I insert those y double prime and y prime and y, I get this. So on the left hand side, you have terms like t times e to the power 3t on the right hand side, you have the same thing. And on the left hand side, you have e to the power 3t, but on the right hand side, you do not. So what I did in the next line, I have kind of created an extra term on the right side, which is 0 times e to the power 3t. All right. And then I compare the coefficients. So t times e to the power 3t, t times e to the power 3t. So the coefficient on the right is 6, coefficient on the left is negative 15 over 15a. So negative 15a must be 6. That gives me a is equal to negative 2 over 5. Then I take this a value and plug it into this to get b is equal to this. And finally, my y sub p, y particular solution, or the particular solution is going to be negative 2 over 5 t times e to the power 3t and negative 4 over 75 e to the power 3t. Finally, my solution is going to be sum of these two. So my y of t solution is going to be sum of the homogeneous part and the particular part. So y of t is going to be equal to c1 e to the power 6t plus c2 e to the power negative 2t plus this particular solution, which is going to be actually minus 2 over 5 t times e to the power 3t minus 4 over 75 times e to the power 3t. So this is going to be your solution to this differential equation. I hope that this discussion was helpful. Thank you very much.